It's math time with Heinz. It's math time with Heinz. It's math time.
Hi everybody, welcome to lesson 3 here where we're going to keep working with these complex numbers. So find the following products. What do we notice? So let's find the product here of 3 plus 2i and 3 minus 2i. So I'm going to make a box, right? 3 plus 2i, 3 minus 2i. And then all I need to do is multiply, just as if I was a variable here and not that special complex number that we learned about in the last lesson. So 3 times 3 is 9. 3 times 2 is 6i. 3 times negative 2 is negative 6i. And then careful here, 2 times negative 2 is negative 4i squared. So now that I have all those pieces, we've got to pause for a minute because I see an I squared here. And last time we were together, we learned that I squared is negative 1. It's this weird number. It's this imaginary number that when we square it, we get negative 1. So this is really negative 4 times negative 1. So I got 9. Those guys became 0. And then negative 4 and negative 1 makes a positive 4. So 9 plus 4 is also known as the number 13. So the product of these two complex numbers is the number 13. Let's do this second one here. Negative 5i minus I, negative 5i plus I. What goes on when I multiply these together here? Well, I get negative 5 minus I, negative 5 plus I. So I get positive 25, positive 5i, negative 5i, and then careful, negative I times I is I squared. So negative I squared, so that's negative 1. So I get 25. Those terms add to 0 there again. That's weird. And I get a positive 1 there. So this product comes out to be 26. So what do we notice here is we're getting real numbers. Our product is a real number. And that's not by coincidence. Our product is a real number. Why is that happening? Well, because these two complex numbers are what we call conjugates of each other. 3 plus 2i, 3 minus 2i. Negative 5 minus I, negative 5 plus I. It's where I have that same binomial with just a different sign in the middle. So let's find the product of x plus yi and its conjugate. So the conjugate, all conjugate means is change the middle sign, x minus yi. And this should look familiar to us, and we're going to talk about what it is in a second. This should look familiar, x plus something, x minus something. Think about where we've seen that before while we find this product here. So we get x squared, xyi. X times negative y is negative xyi. Careful here. Y times y, negative y squared, I times I squared. Be careful with that box there because you got a lot going on. Remember, I squared is just a sign changer, so that box is really positive y squared. Like it did in the beginning, those terms added to 0, and I'm left with x squared. So the product appears to be x squared plus y squared, which is weird because this is the sum of perfect squares. So it appears that I can now factor, and we're going to do this later on in the unit, it appears that I can now factor the sum of perfect squares, which is going to be a really eye-opening process when it comes to polynomials later on. Right? I took x squared plus y squared and I factored it into two different binomials. We couldn't do it before, but now that we've got our friend this imaginary number, the sum of perfect squares is going to be fair game. So again, the vocab word conjugate, I just want you to realize it means change that middle sign. Let's play around with some square roots for a little bit before we start practicing. So we used to panic when we had a square root of a negative number, but now all we're going to do is we're going to take out that square root of negative 1, we're going to take out that negative and throw an I outside of the radical. And now it's just like 9th grade. How do I tear apart 32? 16 times 2. So 4 radical 2 with an I stuck on at the end. So whenever we see a square root in a radical, we just take out a factor of I. All right, so I've got 2i, the square root of, I'm just going to take out an I there. Whenever I see that, I'm just going to take out an I, plus the square root of 36i. Well, wait a second. I know what this is. This is 2i times 5i, right? Square root of 25 is 5, plus 6i. So whenever I see, so if I had the square root of negative 49, I can say, wait a minute, the square root of 49 is 7, but I'm going to throw an I on at the end. Same thing here. What's the square root of negative 25? Well, it's 5 with an I. 2i, so this gives me 10i squared plus 6i. And hopefully you're saying, Coach, look what you got there, bud. You got an I squared, which I do. So it's really negative 10 plus 6i. So when we deal with radicals, when I deal with the square root of negative chicken nugget, all I do is I get the square root of chicken nugget times I. That negative drops out and comes outside the radical as that imaginary unit. Okay? We're going to be encountering that a little bit going forward, and we're going to skip this crazy problem here to get to some good practice. So I'm not going to stop the video on you right now, but maybe you pause the video and then try the problem and then come back. I'm not going to force you to do that, but that's what I would strongly recommend if you want to get good at this instead of just watching me. So if x is a real number, express this in simplest a plus bi form. So I need to clean this up here. And the first thing I see is I see an I squared. I see an I squared and I say, you know what? I'm going to change the sign. I plus 4. It's a sign changer. That negative became a positive. And now I'm going to distribute. Again, you could have distributed to at the start, but I'm just going to get rid of that I squared. So 2xi squared plus 8xi. But wait a minute, look what popped up again. I squared is a sign changer, negative 2x plus 8xi. It looks weird, but we're done. Why? Because it's in real plus imaginary. Real number, there's no I. Imaginary number, it's got an I. That right there is my final answer. Okay? So you just have to recognize, oh wait, I've got I squared. That's negative 1. Express negative 3 plus 3i cubed. All right, well, cubing something means I have 3 of them being multiplied together. So let's start with these first 2 and make a box. Let's start with these first 2 here and make a box and see what happens. So I get positive 9, negative 9i, negative 9i. 3 times 3 is 9i squared. All right, well, I'm not going to panic because I know what's in this box here really. What's really in that box is negative 9. I have negative 18i and a positive 9. So I have 9. Wait a minute, 9 minus 9, those guys add to 0. So these first 2 binomials really just become negative 18i times negative 3 plus 3i. So I found the product of these first 2. Now I've got to multiply that last factor by it because I wanted it cubed. So I'll distribute, I think that's 54i minus 54i squared. Oh, look who popped up again. That's why I said this is so important. I squared is my sign changer. But I'm not really done yet because it's not in a plus bi form. It's not real plus imaginary. The real part plus the imaginary part. That's really my final answer there. 54 plus 54i, real plus imaginary. Create an equivalent expression equivalent to 3 minus 7yi squared. Well, I know how to square something. I'm going to make a box. 3 minus 7yi, 3 minus 7yi. 9, negative 21yi, negative 21yi. Careful, this last box here is a mess. Negative 7 times negative 7 is 49. Y squared, I squared. Make sure you're very careful multiplying all those terms together there. Make sure you're very careful multiplying all those terms together there. So we get 9 minus 42yi. And then wait a minute, I see an I squared here, so that just is going to become a negative 49y squared. And that's basically my answer. That's basically my answer there, because there's nothing I can really combine like term-wise there. So I'm going to leave that as my answer. We'll do two more together, and then I'll let you guys go. Create an expression equivalent to x plus 3i squared minus 2x minus 3i squared. So we need a game plan here. We've got to square this. We've got to square that. And then finally, step 3 is to subtract. So first we've got to square. Again, you should be getting somewhat faster at these now. X squared, 3xi, 3xi, oh careful, 9i squared. So that purple piece really becomes what? That purple, let's get that 10 out of the way. That purple piece is really x squared plus 6xi. Ooh, what's really down here? Negative 9. Minus whatever I get in my green parentheses. So I need to make another table. 2x minus 3i, 2x minus 3i. 4x squared minus 6xi minus 6xi. Careful, positive 9i squared. But I know that sign is really going to change. So I get 4x squared minus 12xi. Sign change there to negative 9. So that was step 2. And now my final step is to subtract with a little distribution. Okay, so our rules of algebra still are in effect. You still have to follow your order of operations. So to subtract, I have to distribute through that factor of negative 1. So I end up with negative 3x squared plus 18xi, and those terms add to 0. So that right there is my final answer. I'm going to have you guys try a very similar one right here on your own. Again, 1, 2, then step 3 is to subtract. That'll be in your Google form, but let's end with this question here. Write this expression in simplest a plus bi form. All right, well, there's a ton of stuff going on here. First of all, I to the third. I times I times I, those guys become a negative 1. So I have negative 1/2 times negative 1i really becomes positive 1/2 I. That's what this first piece becomes. I saw I to the third, so I kind of clean that up. There. Then I've got the square root of negative 9, which I know the square root of 9 is 3, so this is just going to be 3i minus 4. But then I see another I squared term here, but I know how to handle that. I'm going to do a sign change, so plus 3. It cleaned it up a little bit because now I've got to distribute. I've got 3/2 I squared minus 2i and a plus 3 just hanging out over here. I squared again. It constantly pops up. So negative 3/2 minus 2i plus 3. And now I got to combine my real pieces together. Negative 1.5 plus 3 is positive 1.5 minus 2i. Make sure you write it in real plus imaginary form. Real plus imaginary. You could have left that as 3/2, or you could have gone as 1.5, but I combined my like terms right there. Okay, so hopefully you feel better working with complex numbers. The key thing to remember, I squared is your sign changer. I squared equals negative 1. And we'll keep working with complex numbers as these lessons progress.